Now, welcome to the channel, STEM Cafe. Please, if you have not subscribed, kindly subscribe, share, comment, and follow. The question is under permutation, combination, and probability today, and I think it will help us if we can handle this question. Find how many ways 15 children can be divided into 3 groups of 5 if A, there are no restrictions, B, 2 of the children are brothers who must be in the same group. Very easy. Let's look at how we do it. You know, in the first place, there are no restrictions. We are going to divide them into 3 different groups of 5. So which means that for the first group, we have to select 5 from 15. It will remain 10. Then we have another group, 5 from 10. Then we have the last one. We have 5 will remain, and we select 5 from there, which is 1. So we are going to have it like this: 15 combination 5. Then we are going to have this next: 10 combination 5. You know, after we have selected 5 out of 15, we have 10 left. Then we are going to have 5, 5. So let's see what that gives us. So 15 C5 is 3003. 10 combination 5 is 252, and 5 combination 5 is 1. So that's the answer. So those are the number of selections or groups you can have if you divide into 3 different groups of 5. Now let's check B. The second part says 2 brothers must be together. And what does that mean? It means that once we have to remove the 2 brothers. That is, we have 2. Then we are going to have 13 left. Now that we have these 2, it means that we have to divide them in such a way that 3 will be left in a place. And once 3 is left in a place, we will now be able to add that 2 to the 3 left. So what is going to happen is this 13, we can divide it like this: 13C5, just like above, times 8C5, you understand? Times 3C3. This 3C3, we are going to add this one, 2C2. Or we can also have it like this: 13C3 times 2C2. So we will now be able to have 10C5 times 5C5. Or we can have it like this: 13C5 times 8C3 times 2C2. What we are saying is this: the 2C2 must combine with the group that is having 3 times 5C5. So by the time you do all of this, you realize that they give you the same answer. Let's see what it gives us. So you can see, either way we select it, either way it's going to give us 72072. So I just feel I should give you this explanation and treat this question, so you can see the dynamics in handling permutation, combination, and probability. Let's quickly look at another one. Very interesting. Now, 8-digit mobile phone number issued by Lemon Network all begin with 79. A. How many different phone numbers can the network issue? B. Find probability that randomly selected number issued by this network. 1. End with digit 97. 2. Read the same left to right as right to left. Now, since there is no restriction for each, let's see. Let me put it here. We have 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the way the numbers are issued. But for each number, you know, they have their own, how do I put it? Identity. That is the first 2 numbers or first number. So for this one, the first 2 numbers are 7, 9. These are permanent. They cannot change. But these ones, they can change. And for each column, you have possibility of 10. So for this place, you have 10. So this place is 1 like this. For this place, you have 10. 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 So what do we have here now? The total number of numbers, the total possible different phone numbers that can be issued are or equals 10 times 10 times 10 times 10 times 2, 3, 4, 5, 6. What that means is, for this place, it can be repeated. You remember, where repetition is possible. So we are going to have 10 raised to the power 6 or 10, 1 million. I think that's 1 million. So that's the possible numbers or full numbers you can have. Now let's go to the second part. So we are asked, find the probability that the randomly selected number issued by this network ends with 97. So now let's end this place with 97. So just like this place, we have this place fixed. And you know the mindset is this. This place is 1, 1. And this place too is 1, 1. They are fixed. That is why we have it like this. Now, but these places vary. So just like before, we have 10 here, we have 10 here, we have 10 here, we have 10 here. So the total possible number that we can have that can end with 97 is equal to total possible full numbers that ends with 97 is equal to 10 times 10 times 10 times 10 is equal to 10 raised to the power 4. And so the probability of number ending with 97 is equal to 10 raised to the power 4 divided by 10 raised to the power 6. And how do we get the 10 raised to the power 6? You remember the 10 raised to the power 6, that is the total possible numbers that can be issued. That is numbers that ends with 97 over total possible number is equal to 0.01 or 1 over 100. 0.01 or 1 over 100. So that is the probability for a number that ends with 97. Now let's look at the second part. It says read the same left to right as right to left. So what does that mean? It means that from here, here, we have already had this space fixed. So this space 2, they are already fixed. And how do we have now? We are going to have 7, 9, 7, 9. Can you see? So these places are already fixed. They are already fixed. You understand? So what happens now? But this place is now. Let's look. If this place has 10, because we can have 10. But the situation now is this. Anyone that comes here must appear here. So if anyone appears here, we are going to have 1. You understand? That is, if we have 10 possible numbers here. But any number that appears here must be the one that appears here. So we have 10 here, 1 is possible here. Because just like this place and this place, we have 1, 1. So this is 1, 1. These are just the figure, not the possibility, please. Let me change it. So this place is already 1, 1. Just like before, we have 1, 1. So this place is 1, 1. They are still retaining their distance. So if this place is 10, this place will be 1. Because anyone that appears here will determine what will appear here. So this one does not change. It is what is here that will determine what is here. Now, this one too, this place will be 1. You can see. So since we have 10, 10, 1, 1, 1, 1. So since we have 10, 10, 1, 1, 1, 1, and this place is 1, 1. So the total number with arrangement, the same arrangement, left to right as right to left is equal to 10 times 10. 10 raised to the power 2. Now the probability, just like before, the probability of same arrangement left to right as right to left will be equal to 10 raised to the power 2 over 10 raised to the power 6. Just like before, this is the total possible number, and that's going to be 1 over 10 raised to the power 4 or 0.0001. So that's the probability. You can see it's just to show you how to reason when you are handling different types of questions. So the first one is a combination. This one is permutation. Thank you. So kindly subscribe, share, and whatever you think we should do to encourage us. Your advice is welcome. I appreciate it. Thank you very much.